So I want to talk about how the concept of organs can make us have more useful and less wasteful consumer electronics. But first, I want to talk about how generic products suck, right? And product designers know that. So rather than designing one object for a lot of people, they design a few objects for a lot of people. They try to sort of gather all of everybody's needs into a nice, tidy set of groupings and put them together. And the problem with modern manufacturing is it only lets designers design a few solutions, okay? Now, the reason that that's a problem is that we know they're generic. We know they don't work for us, and we throw them out. We get something better. And all of those thrown out solutions add up to quite a bit of waste. But that waste is getting recycled, right? In places like China or here in Ghana. So it's good. Well, it turns out it's not that simple. In fact, most of the problem with consumer electronics isn't that there's matter, it's that there's energy embodied in those electronics. And actually, those electronics have 3 orders of magnitude more energy per kilogram than, say, a wooden chair, right? That energy is involved in informing the electronics themselves, so like the order that's in those electronics. And when you grind them up and melt them down, you lose something. It's sort of like taking a sausage, trying to make a pig out of it, right? It just doesn't work. It doesn't work very well, and that's what we're doing with electronics recycling. So, if manufacturing isn't actually meeting our needs, and if this diversity that we're making is only making more waste, and if we can't recycle that waste, what are we going to do about it? Well, there's another model, okay? Nature makes organisms in a different way than we make consumer electronics. Nature is modular. Many of you may have replacement bits, hearts, livers, kidneys, knees, and you swapped those out because they were no longer working for you and you upgraded, right? If we could make electronics more modular, more upgradable, and more importantly, more remixable, right, we might be able to get better products, and we might be able to get them at less waste. SSG, or skin, skeleton, guts, is a framework that I've developed that tries to get at those kind of electronics. So, in this new framework, we need to have a community to develop these products. Rather than having one designer dictate what we should get, we should allow lots of people to contribute to that conversation. In order to do that, we need to break that conversation up into little pieces because, you only really know about one small part of what's right for you. And so if you could work on that small part, then you might be able to create part of this global conversation of what is the right object, what is a good object. How are we going to make those modules work? Well, nature makes them work in a couple different ways. The guts, right? In nature, hearts are pretty much the same in mammals. So here's a pig heart and a rat heart, basically the same, just scaled up to fit the different sized animal, okay? Those modular parts can get swapped around. So all mammals have hearts. In these electronics, these are made by a company called Liquidware, and they actually are rearrangeable modules that can be gathered together to form everything from a scientific calculator to a Linux, kind of an iPad ripoff on the right there. The skeleton in nature is also modular, and it's built in a really nice way so there's no glues, no screws that can fail. Right? This pinky looks like it's having a bad day, but really you could pop that into place, be pretty good as new in about a week. Likewise, in SSG design products, the skeleton doesn't use screws and glues that could break like they might break on your cell phone. The skeleton in this watch is actually a simple kind of keyed connection of simple plastic parts that is really easy to produce. You could 3D print it, you could carve it out of wood, depending on what kind of access you have to tools. Finally, the skin. The skin is the thing that holds everything together and makes it look beautiful, right? So it has an aesthetic and a functional aspect. In SSG designs, the skin is what takes the place of those components, like the glues, like the screws, that would normally hold everything together and hold that product together. So in this case, in the case of the SSG watch, the skin is what holds that together, but it also gives it a nice aesthetic. And so if you know how to sew, you could easily swap out the skin, have a black watch, have a red watch, have a different watch. Because the modules are self-contained and can be changed individually, it allows anybody who can sew or who can route a new circuit board or who can 3D model, right? So these very different people, probably somebody can't do all three of those things, but you might know somebody that can do one of those things that could help you. Okay. These kinds of systems can be applied to more complex devices. So this is a concept cell phone that also shares its guts with an e-reader, very much like a Kindle. The same guts can be used in both. So if your cell phone broke, if the screen broke, for example, and you maybe bought a whole new cell phone, you could still fold those modules forward into a useful device without having to ship them to China to get melted down. If we could enable this global cloud of possible modules, then we could start to see real, spontaneously nucleated solutions to local problems. So someone in New York or Seattle might choose different modules to use to solve their e-reader or watch problem versus someone in South America who would have different local access to materials and different local access to fabrication. So SSG allows us to reduce waste, and it allows us to get better, more useful products, but most importantly, it opens up innovation to the whole world of potential collaborators that could exist if this cloud were real. Thanks very much.